Hello, we're back with our data. In this video, we're going to be talking about calculating variance, standard deviation of our data set, and then also how to calculate z-scores of our data set. So I'm going to go ahead and erase these notes I made last time just because, I could leave them, I suppose. Okay, so at the very end of the last video, go check it out, we interpreted the mean and the median. We said because the mean is greater than the median, what's happening is it's skewed right, meaning we have several data values that are pulling that mean to be higher than like the direct center, which is the median of that data. So this data is skewed right, and we briefly showed here, if we look at this histogram with this bin width, it does look skewed right, where this is the tail, and the majority of our data is over here towards the left. So this is right skewed. To me, that's like counterintuitive to call that right skewed. It feels like you would call it where the majority of the data is, but that's not what we do. So just noting that if your brain doesn't like that and you are tempted to call this left skewed, just understand that I struggled with that for a very long time as well. Think about where the tail is. So the skewness is where the tail is. Okay. In this video, like I said, we're mainly focusing on calculating, I'm going to unhide our data set, calculating variance, standard deviation, and z-scores. So we calculated an estimate for our mean in the last video from a grouped relative frequency table, pointing out again that was an estimate because this is assuming we don't know the data set. But we do know the data set, so we can calculate the actual mean here, which we've done in a different video. So now what we're doing is focusing on variance, standard deviation, and then also how to calculate z-scores. I'm going to go ahead and widen this so we can include all of our words. Okay, and z-scores, I'm actually going to merge this cell because we're going to do several examples of z-scores, how to calculate z-scores. Okay, so here we did the range of usual values. And in fact, I'm actually gonna, I just don't want us to get confused that somehow this is part of the range of usual values. So I'm gonna go ahead and do this to kind of make like a block. This is the range of usual values. There we go. Variance is different from the range of usual values. Alrighty. And then we'll merge this one again. Okay. To find the variance of a data set, sorry about that, my formatting, I just like to make it clear for y'all. All right, equals VAR is our variance functions, is where we pull these up. So we have VAR.P and VAR.S. So we will start learning that when we have different functions that have a .P and a .S, this is referencing a population and a sample. So in this case, what we are looking at is a sample. We have collected a sample of 44 guesses. So what we're going to do is come over here to var.s, and this says estimates variance based on a sample. Okay, so var.s, and then it wants you to highlight our whole data set. So we can do that. Equals. And this is our variance. That's a very high number. What that means is there's a lot of variation in the data. Okay, standard deviation. The first thing I'm going to do here is calculate this using our Excel function, but I want to verify something that we have learned in our course so far, is that standard deviation is the square root of variance. So first I'm going to find this using our standard deviation. Now the standard deviation function is STDEV. So standard deviation population, standard deviation sample. So this is a sample. We are going to sample. And we will highlight all of this. Come back up. Enter. So this is our standard deviation. Okay. What I want to verify, like I said, is that the square root, so we can actually use square root functions in Excel. So square root function is SQRT. This returns the square root of a number. So the square root of variance should give us standard deviation. This is what we've learned in our class, is that the standard deviation is the square root of variance. That variance is the square of standard deviation, which I will show you how to do that in Excel as well. So the square root of this is the same number. Yay! This is very satisfying. I always get slightly nervous right before I hit enter that I've done something wrong, but you know, math makes sense. So here we have it. Square root of variance is the same as if you were to calculate it using our Excel function. And as a reminder, what variance and standard deviation are doing is they're calculating essentially several differences. So our mean here is 400. I'm just going to say 429. I'm going to round. The mean of our data set is 429. When we calculate the variance and standard deviation, what we are calculating is how far away each of these values are from that mean. So we're taking, for example, 213 minus this to show how far away this is from the mean. And we're doing that for every single data value. And then we're doing some other mathy things to it, like squaring and square rooting. And what we're doing is finding the distance. Like actually, if you, I'm just gonna like name drop the Pythagorean theorem, the distance formula. That's what we're doing. So we're finding the distance between each of these data values and the mean. And then basically summarizing this in a number. So this means that there was a lot of distances between data values and the mean. And the variance and the standard deviation, because they're directly related, the standard deviation will also be fairly large then. Okay, so I also want to point out here, if we take this number, we can square it. So to point out, variance is the square of standard deviation, because squared and square root, these functions are inverse functions. So they should work in opposite directions like this. So if we square the standard deviation, we should get the same thing here. Perfect. Okay. So that's variance and standard deviation. I will say standard deviation of a sample, we use S to represent that. So again, I'll say the mean that we have found is a sample mean. So X bar is for a sample mean. We've already talked about N represents sample size of a sample. And then standard deviation of a sample is S. We also will see in future videos, population mean is what we call mu. It's a Greek letter mu. And then population standard deviation is the Greek letter sigma. So we'll get into that later, but just wanted to kind of foreshadow those. All right. And now jumping into z-scores. So for z-scores, we need to know the standard deviation. So what a z-score is, a z-score is the number, in fact, I'll abbreviate this so that we can fit it, the number of standard deviations away from the mean. And this is for data values. So like this is how many standard deviations away from the mean a data value is. I'm going to realign this so that we can see it. Oh, and it says data value. Okay. So z-scores is the number of standard deviations away from the mean that a data set, that a data value is. So as an example, if we wanted to consider, I'm going to click on 350 here. Let's look at the data value 350. And I'm even going to write x equals. So we're going to reference our formula as well that we've learned for z-score, but then show you that Excel can also calculate this for you. So if we consider the data value of 350, so the z-score formula that we've seen is that we take the data value. Oh, except I can't click it because I typed the x in there, so Excel would be frustrated with that. So I'm gonna do it this way, but we take 350, we subtract the mean. And that might feel funky because we're going to get a negative number there, but that is intentional. So if a number is below the mean, we often use negative signs to indicate it's like less than. So what will happen with z-scores, we always put the x value or the data value first and subtract the mean. Because by doing that, if you put your data value first and it's less than the mean, it will make your z-score negative, which is what we want. So here we have this data value minus the mean, and notice I self-referenced up here. The mean is this value. And then what we do is we divide by a standard deviation. So what we're doing here is essentially finding the distance between this data value and the mean, but then standardizing it or normalizing it in a way. And then we can start comparing z-scores very quickly for values instead of comparing values themselves. And we can jump into that in our summary video when we really jump in and like analyze and interpret all of these things. But the z-score is finding the difference and then normalizing it by the standard deviation. So we divide by the standard deviation. So the z-score of this value is negative 0.265. What that means is the guess of 350 was 0.265. I'll say about, because we round, was about 0.265 standard deviations below the mean. And I want to clarify, by below, I mean less than, which we can verify. 350 is less than the mean, so our z-score should be negative. Okay, let's go ahead and grab an example above the mean. So our mean, again, was 428, rounded down. So let's go 850. Okay, so 850 as our example now. What we're going to do is parentheses 850, so our data value minus our mean here, and divide by our standard deviation. I'm doing this this is essentially how we do it by hand, but y'all, Excel has a function for this, which is really great. So what I'm going to do is show you this one more time this way. So what we're doing is finding that difference, dividing by the standard deviation. That is the z-score of 850, meaning the guess of 850 is 1.42 standard deviations above or greater than the mean. Okay, I'm going to make all of these, I just like 3 decimal places, I think. I'm figuring that out. Okay. Okay, so what we're going to do is 850, but now we're going to use the Excel function for this. So the Excel function, if you see, is standardize. So standardize here, it says returns a normalized value from a distribution characterized by mean and standard deviation. That's talking about a z-score. So if we click here, notice it's asking for x, which is this value. So it's asking for what data value you want to consider. Then it wants you to go click on your mean. So you can go click on your mean. And it color coordinates this. So blue is, at least in the way the order I'm clicking on it, blue is the data value, red is the mean, F5, and then the standard deviation, we can click here. We could also click on either of them. They have color coordinated that to be purple. And this is calculating the same thing. It's just inputting these values into this function for you. And so it calculates it the exact same way. It's just kind of doing it maybe slightly more efficiently. So I'll highlight that again. It's equals standardize. And then you click on your data value, the mean, and your standard deviation. And again, what this means is the guess of 850 was about 1.419 standard deviations greater than the mean. Okay. So this is how we calculate variance, standard deviation, and z-scores in Excel. All right, and then in another video, we're going to jump into actually analyzing and interpreting all of these things to talk about our data set and how it's distributed. And I'll reveal the real number of candy corns in that video too. All right, thank you. See you soon.